Hey Opties! Today we're going to be talking about segment addition. You have learned about angle addition previously, and segment addition is a very similar idea. You're taking an original segment or a total segment, you have it sectioned into two or more pieces, and you're adding up the pieces or the parts to equal the total original segment length. So part plus part equals whole, just like in angle addition where we had part plus part equals whole. You can, however, solve for a part by taking whole minus part and equaling it to the part. Let's just read the definition here, which is just basically what I already said. When finding the length of a segment that is broken up into parts, the sum of the parts equals the whole. So the sum of the parts equals the whole. That's another way you can say that instead of just part plus part equals whole. Let's take a look at our segment CT. It has a point in between the endpoints of the original segment, which is CT. When you put a point on a segment, it automatically will make it into sections. Notice we have one point, which is A. And how many sections do we just section it into? Two sections or two parts. What if we put another letter there? Another point. 2 points would now make 3 sections. So if you can kind of see the pattern developing, the number of points you add to a given segment will always make one more number of parts. 1 point in between the endpoints on a segment will make 2 parts. 2 points will make 3 parts. 3 points will make 4 parts, and so on. It's probably the simplest to start by looking at just 2 parts to making one whole. So that's why I just showed you the 2 parts to begin with. When there are points that are all on the same line or segment, those points are called collinear because they are on the same line. Co means like together or at the same level. Think about co-captains, right? Co-captains, one of them is not above the other. They're on the same level of authority. So collinear means you're on the same line. Linear to represent the word line. It can also work for segments. So CAT are collinear. A is between C and T. So CA is a part, AT is a part, and CT is the whole. And we can see that in our orange equation written in the words and also the letters. Let's take a look at whole minus part equals part. There are 2 different parts. So if you're solving for, say, CA, then your equation would look like CT minus AT equals CA. If you're solving for the other part, AT, the second part, then your equation would look like the whole CT minus the other part, CA, and that would give you the length of AT. So that's the general idea. Let's take a look at some practice. This is just with numbers, and then we'll have some practice with algebra in just a moment. Number 1, our orange picture. We've got the same segment, and it asks us to find the length of CT, so that'd be the total length. And we're given that CA is 6 units and AT is 3 units. Now before we label our picture, remember you always label your picture with your given information. I want to discuss why there is a line on top of CT, but there are not lines on top of CA and AT. The line on top of 2 letters where there are no arrows is telling you that that is a segment. Now, CA and AT are also segments, but I don't have to put a line because I'm talking about their value. The reason there is a line on top of CT, that segment notation for just that line without arrows, is because we're like basically naming CT. We're not saying CT equals a number value. That's what we're going to find. So when we write our answer, we're not going to have the segment bar on top of CT. So that's the differentiation there. Now let's go ahead and label our picture. CA is 6 units. AT is 3 units. This is part plus part equals whole. So CA plus AT is CT. Notice that C is in one of the parts, T is in one of the parts, and your whole is CT. And then they share a letter, A. They share that letter, that's because that's the point where those two segments meet up. So if you're looking at a multiple choice and they're like, which of the following is true? This plus this equals this, and it's part plus part equals whole. Make sure you're looking that the whole has one of each letter in each part, and then each part is sharing one letter. That's a quick tell to be sure that it is part plus part equals whole. So let's go ahead and do this. CA is 6, AT is 3, 6, 7, 8, 9. Okay? So CT, no bar because I'm talking about the actual value, is 9, and we just have units here. Not any specific units, just the word units. So we're done for number 1. Let's take a look at number 2. Find the length of CA. Okay, so this one's different because we're going to find the length of a part, not the whole. So we're going to be using one of the whole minus part equations. So let's go ahead and mark a question mark there. Given CT is 15 units, okay, so the entire thing is 15, and AT is 6 units. So let's write our equation. We want to find CA, so it's going to be whole minus part equals part. This part has to be the question mark, the thing we're going to find. You technically could do it with this being the part, but it's most straightforward if you set up the equation where you're equaling up to what your question is. Otherwise, you're going to have to do a little bit more steps. You could do it though. So this is CA. The other part is AT. And our whole is CT, which is 15. So I'll go ahead and write the letters like the other ones. So now let's substitute. CT is 15. If you wanted to draw this, what I like to do, and I know it's running into the other question a little bit, you could put that little bracket type of thing, little curlicue bracket, and to show the full thing. A lot of people like to just do, like, if here's your segment, a lot of people like to do this sort of bracket, and then you could write 15 here. If you can't do the squiggly, you can do it like this, or this is a squiggly. So there's just some methods you can use to label the entire one. Let's finish up our subtraction here. So 15, which is CT, minus AT, which is 6, equals CA. That's what we're trying to find, so it stays as CA. So let's continue that over here. 15 minus 6 is 9. So CA equals 9 units. Now, the fact that these both have the same answer is just coincidence. So don't read into that or anything. Finally, we have a practice problem with algebra. Number 3 says, find the length of CT, so this is the whole, so another part plus part equals whole, given CT is 6x plus 2 units, AT is 2x plus 1 units, and CA is 3x plus 3 units. So we know that it's going to be part plus part equals whole because we're trying to find CT. So this is our question, but it's also given to us as an algebraic expression. We just need to find out the numerical value, so the actual length. So we'll find x using one of these 3 equations, and then we will substitute our x value into 6x plus 2 to figure out the numerical length of CT. So that's our strategy. Let's continue to label our picture. AT is 2x plus 1. And CA is 3x plus 3. Remember, always label your picture. Okay, let's go ahead and set up our equation. You could actually use any of these 3. You can always use any of these 3, but the one that I would typically go for is the one that has an equal sign to the thing I'm trying to find. So we're trying to find the whole, so I probably would use part plus part equals whole. But again, you can use these. It will work. You just have to do a little bit more work, just a few more steps. So let's use part plus part equals whole. So our part plus part is whole is CA plus AT is CT. CA is 3x plus 3, so I'm just substituting right now. AT is 2x plus 1. And CT is 6x plus 2. We've set it up. That's our main first step. Really, our first step is to label our picture. Then we want to set up our equation. Now we're going to solve for x. And our final step will be to substitute our x value back into the expression for CT to find the numerical length of CT. So let's go ahead and solve this equation for x. On the left-hand side of the equation, we are going to combine our x terms and we're going to combine our constant terms, or just our number terms, as they're called, our constants. So let's start with our x terms. 3x plus 2x is 5x. 3 plus 1 is 4. And let's go ahead and keep our equal sign, and we have our 6x plus 2. Now, let's start moving things together between the two sides. Let's put our x's together. So one way we could do that is subtract 5x. We could also subtract 6x, but if we subtract 5x from both sides, then it keeps our x positive. I personally would rather deal with positive numbers than negative. Typically, it's a little easier. It doesn't matter, though. So 5x minus 5x is 0, so that simplifies to 0. Let's go ahead and continue that up here. So on the left-hand side, we have a 4. 6x minus 5x is just 1x, and we still have our plus 2. There's one more step to find x. Let's subtract 2 from both sides. 2 minus 2 is 0. So the left-hand side is just an x, and 4 minus 2 is 2. Now we have x. One last step. Figure out what CT is by substituting into the original expression. So CT is 6x plus 2. Let's substitute. 6 times the x value we just found, which is 2, plus 2. 6 times 2 is 12, plus 2 is 14. And that is going to be in just units. We're not given inches or feet or anything. That's it for our algebraic practice problem, and that's it for segment addition. See y'all next time.